nature has produced an even better fiber, one with properties that have been perfected over 300 million years of evolution. A fiber that can now outshine all the others. Spider silk. That's why biochemist Thomas Scheibel is not afraid of spiders. He admires them. His idea was to manufacture spider silk the way nature does, and to take advantage of its properties. The exciting thing about spider silk as a material is that on one hand it's mechanically the most durable material we know. Spider silk combines strength and elasticity. And on the other hand, spider silk is practically sterile. That means it can be used directly on or inside the body. And it's been known for thousands of years. There are descriptions from antiquity about spider silk being used to dress wounds. But raising spiders in large quantities and harvesting their silk naturally doesn't really work, because spiders are cannibals. They would devour each other. That's why, since the 1980s, researchers have been working on a different approach. They want to recreate this miraculous spider silk in the laboratory, using genetic engineering and biotechnology. The basic idea was simple. From the genetic material of the spider, copy the piece of DNA responsible for spider silk. Then insert it into the genome of some bacteria. The bacteria produce the spider silk protein, and then it can be harvested. As simple as the idea sounds, it still hadn't worked after 20 long years. Many researchers had tried and failed to fabricate spider silk proteins in this way. For us, the exciting thing about the process was, why hasn't anybody done it so far? What's so special about these spider silk proteins that it can't be done? And our motto was, nothing's impossible. We were totally convinced that somehow it could be done. One day, the decisive idea came to Scheibel as he was toying with the problem yet again. The gene for spider silk consists of many individual DNA blocks. The researchers usually associate those with short additional DNA pieces. This creates a genetic copy that's not quite exact. So every attempt fails. Scheibel's suspicion was that the connectors were to blame. So what would happen if they were left out? What if Scheibel could find a way to seamlessly connect the DNA sequences for the spider silk protein? And that was also our first patent, this so-called seamless cloning, to produce genetic information without any extraneous sequence, as it's called. And amazingly, it worked right away. But back then, the molecular tools for implementing the idea didn't exist. Thomas Scheibel's team first had to invent the method for seamless cloning by themselves. The researchers then used the seamless DNA sequence in intestinal bacteria, hoping that they would go on to produce the spider silk protein. And, lo and behold, after more than 20 years of unsuccessful trials, Thomas Scheibel was suddenly the first to recreate this coveted spider silk protein in a laboratory. But only a tiny bit of it. To produce large quantities, they needed lots of bacteria. In a bioreactor, the researchers managed to provide those bacteria with exactly what they needed to mass produce the spider silk protein. At the end of the process, they had a solution that was full of this sought-after raw material. That first step, using biotechnology to mass-produce spider silk proteins for the first time, was sensational. We still didn't have any fiber, though. That came much later. And the journalists kept saying, if you don't have any fiber, the whole thing is pretty boring. At first, it was a mystery how the researchers would make fibers from the spider silk proteins. It took the team 10 years to decipher the chemical and mechanical tricks inside the spider's body. Then they tried out the natural process in the lab. Finally, they succeeded. From the proteins, they created the first ever artificial fiber made of natural spider silk, meter by meter. Since the genes for the spider silk had been slightly modified, the fibers from the lab were even more elastic and stable. If you wanted to stop a Boeing 747 while it was landing without using its engines or brakes, one thumb's width of spider silk rope would be enough to do it. You need a bit of a run out though, around 3.8 kilometers, because spider silk is elastic, but then the plane would come to a standstill. BioSteel is the name Thomas Scheibel has given to his spider silk fiber. Meanwhile, the startup AmSilk in Munich is producing larger quantities of it. For demonstration purposes, a sports shoe has already been made. But sports and outdoor clothing are not the only conceivable applications by far. Thanks to their special properties, spider silk proteins can be used in all kinds of areas. You can also produce other materials with the spider silk proteins, of course. Coatings for implants, like silicone implants, for example. You can use them to package active ingredients, then deposit them inside the body and release them slowly. And don't forget cosmetics too. Now everyone can have silky smooth skin. Of course, we have more products already available as prototypes, and we're expecting those to arrive on the market in the next few months or in 1 to 2 years' time. So the technological platform to manufacture spider silk proteins is only the beginning. The potential applications seem infinite. The market for textiles and industrial yarns and threads alone is worth around 50 billion euros. There are 45,000 known species of spider in existence, and all the properties of all the fibers they produce have yet to be discovered.